Decision function theory basics. Image processing steps. Segmentation, labeling, characteristic extraction properties, and classifier. A pattern is a set of characteristics in an image. The characteristics of an image can be topological, such as proximity or texture, geometry, such as size, length, or area, and statistics, such as shape or color. We can store patterns in various formats. The most usual is a vector. Pattern recognition systems. A pattern recognition system consists in a sensor that gathers the observation to classify, a feature extraction system that transforms the information obtained in numerical or symbolic values, and a classification or description system based on the structured features. Patterns can be recognized by cross correlation and locator transformation, hit or miss. Objectives. In a recognition programs, each pattern is assumed belonging to a category or class. Recognition system must assign each object to its category. Patterns are obtained from segmentation process, features extraction and description, where each object is represented by a collection of descriptors. The recognition system must be assigned to each object category or class set of entities that share some characteristic that differentiate them from the rest. To recognize variants, the following processes are followed. 1. Data acquisition. 2. Feature extraction. 3. Decision making. That is important concept. Recognition process where a label is assigned to a particular pattern. The class, set of entities that share some characteristic that distinguish them from others. Recession class, set of entities that cannot be labeled as any of the problem classes. Classifier is a subsystem that uses a quantifiable entity feature vector and assigns it to one of M classes. Misclassification evaluation, empirical rate error, empirical rejection rate, independent data set, false rejection, false negative, and false acceptance, false positive. Get patterns in different classes so that is incorrect. For automatic recognition, it is important to parents that describe objects from the same class have similar characteristics. Parents that describe objects from different class have different characteristics. Variable selection. That is consists on selecting what type of characteristics or more suitable features to describe the objects. To do this, you need to locate the features that decisively affects the problem. The variable selection might be different according to the sought objectives. For the classification, the relevant feature selection from the total set of characteristics that describe objects is made with two basic reasons: to improve the classification and to increase processing speeds. For the representation, decide which features better represent certain types of objects. Object recognition approach. Statistical methods. Probabilities optimization in the allocation of objects to classes. Non-parametric methods. The space is partitioned according to objects whose classification is known a priori. Geometry focus. The object classification characteristic vectors according to a given partition of space characteristics. The syntax method valid to recognize objects too complex because too many features or classes. Theoretic decision methods based on the use of decision functions. The classification can be supervised and unsupervised. Supervised is if a training set is used to train the system, and unsupervised is where the system doesn't have a set to learn to classify. It is based only on statistical calculation to classify patterns. For a recognition process based on decision method, border decision. Those x vectors such that dw equal db x, considering the border function, this function will take 0 with values when x belongs to the w class and the values less than 0 when it belongs to b. This refers to the minimum distance to the average vector of all parents belonging to the class. Once the characteristic properties of each class were insulated, it is represented by a parent class consisting in the average of all the parents that belong to the same class. The adapting methods by correlation are based on the comparison of the image to classify with one or more parents' image that characterize each class. It is equivalent to the minimum distance if the parents are normalized. Correlation coefficient provides an invariant measure against amplitude change. Bayesian classifier. In most practical applications, probabilities aren't known. In this case, must be estimated from a training set. The multispectral image encodes information in several bands, sensitive to different wavelengths of the electromagnetic spectrum. Bayesian classifiers have proved effective to classify trains in many types of image.